This video is going to be on our introduction to quadratics, which are our parabola graphs. We can see here that I have our parabola on there. A parabola, a quadratic, comes from a second degree polynomial. This is our parent function, no transformations, y equals x squared. And I have our points already here on the graph for us, but remember, if we didn't know this, we could always create our table, our xy table. So I'm going to start there at the middle. If I plug in 0, 0 squared is 0. If I plug in 1, 1 squared is 1. If I plug in 2, 2 squared is 4. If I plug in 3, 3 squared is 9. I could also go negatives, negative 1. But if I square a negative, that becomes a positive 1. A negative 2 squared is a positive 4, and a negative 3, which gives us a positive 9. So as we look at our graph, we want to talk about a couple different characteristics of all parabolas. What we just did in our table of values is that we showed, and we can see it in our parabola, those points, it is going to be symmetrical. So every point on the left is going to have a mirrored point on the right. If you think back to geometry, this is a reflection over your axis of symmetry. The axis of symmetry is that line, you called it a line of symmetry in geometry, which shows that reflection. So this is 1 to the left, 1 to the right, 2 over, 2 over. Your line of symmetry is what cuts your object into those two symmetrical pieces. And in parabolas, what that does is it gives us an axis of symmetry. And I never write that all out, so what you're going to see on your paper is AOS, axis of symmetry. The axis of symmetry is a vertical line, so it's always going to be x equals. And it's always going to go through that vertex of your graph, because that's where your graph is going to be changing directions, so that increase and decrease. That brings us to our second part is, unlike in unit 0, we've got only two different intervals here. It's going to be increasing in one spot and decreasing in the other, so we're not going to have multiple things to fill out. If I look at this graph, I am decreasing here, because remember we read it from left to right, and then at the vertex is where we change directions, and then we are increasing. One thing about your parabolas is that the end behavior is always going to be facing the same way. So we can see our parabola. So the end behavior, if the parabola is opening up, then both of your end behaviors are going to be going to a positive infinity. If your parabola happens to be opening down, then both will be going towards a negative infinity. End behavior, they're going to go in the same direction. You're never going to have one arrow going up in the end and one arrow going down. They both have to go up or they both have to go down. All right, given the graph, identify the equation of the axis of symmetry. So remember, the axis of symmetry is that vertical line that cuts your parabola into two symmetrical pieces. And here, I see my vertex. What you have to do is you have to identify that vertex. So the coordinates of that point is I'm over 6 and up 3. Vertical lines are x equals. So that axis of symmetry is going to go through the x coordinate of your vertex. Number 2, same thing. I'm choosing that vertical line that's going through the vertex. Now the axis of symmetry is actually in an invisible line that goes through. I should be drawing these lines dashed. I look at this and I'm over 8 and I'm down 7. So the coordinates of my vertex are at 8, negative 7. So my axis of symmetry is x equals 8. Vertical lines are always x equals. It always goes through the vertex, so it's x equals the x coordinate of your vertex. All right, a review of our transformations. Remember, transformations are going to be showing up over and over and over again. So we have a parent function. Remember, a parent function is your equation without any transformations. So basically, I just look at my degree. It's a second degree polynomial. So the parent function is y equals x squared. A transformation is occurring everywhere that a number was being added or subtracted or multiplied. So anything that wasn't originally there at x squared is a transformation. We always start by order of operations. So I have to look in here first. This is my first transformation. So I'm going to be going right 6. Inside the parentheses is horizontal, opposite of what you see. Then we go to our multiplier. Now this is the one where only time it doesn't matter the order. You can either talk about the negative first or the 2 first. So the negative tells me that I'm going to reflect over the x-axis. It does make a difference between the x-axis and the y-axis. And the 2 tells me that I have a vertical expansion or stretch by 2. So again, those 2 steps, it doesn't matter the order because they all come from that same term. And then our last one, adding the 7 to the outside, is going to make us go up 7. Does this graph have a min or a max? How do you know? This is important. So when I look at this, I think to myself, does it have a min or a max? If I had a graph that opened up, I have a minimum value. If I have a graph that is opening down, I have a max value. So I have to think about, how do I know if my graph has a min or a max? And it's how it opens, which means it's determined by whether or not it has been reflected. Because this graph was reflected over the x-axis, it's going to be facing down, which means it's going to have a max value. So you do not need to graph it. All you have to do is looking at that a value. If it's negative, that means it was reflected, which means it's opening down, which means it has a max value. If it's a positive, it's opening up, and it has a min value. No need to go beyond your equation. Next one, what are the coordinates of the vertex y equals 1/2 x minus 5 quantity squared plus 4? All right, so this may seem like a really hard question, but think about your graph. The parabola, the vertex, comes from the horizontal and the vertical shift. Remember, you have a parent function. This would be our parent function. And then everything is transformations based on that. I could move it right, I could move it up, I could move it left, down, I could make it a vertical expansion, a vertical shrink. I can reflect it. So the vertex all matters about how did I move it left and right. This tells me that I went right 5. This tells me that I go up 4. I always start at 0, 0. So if I go right 5 and up 4, my vertex is now at 5, 4. So this equation happens to be in vertex form, showing those transformations, which is how I knew how to get to my vertex. Our last one for today, a parabola has an axis of symmetry of x equals 4 and contains a point -2, 7. Find another point on that parabola. So this is going to bring us to our idea of symmetry. We have our little xy grid here. What I do know is that I have an axis of symmetry at x equals 4. 1, 2, 3, 4. So I have this imaginary line at x equals 4 cutting my parabola in half. And I'm going to use the idea that my parabola is symmetrical. And this is that line cutting it into those two symmetrical pieces. I know that it has a point, negative 2, 7. So I'm at negative 2, up 1, 2, 3, 4, 5, 6, 7. So I have one point at negative 2, 7. If this is a true parabola, I have to have the same point on the other side. So it's just like doing a reflection from geometry last year. I count over 1, 2, 3, 4, 5, 6. So it's 6 points away from my axis of symmetry, so I need to go 6 more on the other side. If I'm at 4, I'm now going to be at 10. So my other point, when I reflect, all I did was change that x value. I'm still at 7. So the coordinate of my new point is going to be at 10, 7, showing that symmetrical relationship of the parabola. You count towards the line of reflection, which is that axis of symmetry. You count the same amount on the other side. The y value doesn't change because you didn't change the height, you just changed the x coordinate. All right, that is it for today.